In this video, we're going to do an example of calculating the arc length of a curve. And the problem says, compute the arc length of the curve C with parameterization r of t equals t squared over 4 minus the natural log of t over 2, comma 6, where t goes from 1 to 3. Okay, so basically what you need to do is you need to remember the formula for the arc length. And the best way to remember the formula of the arc length is that you need to integrate the speed. And the speed is the magnitude of the derivative of the position function. So the arc length of C is going to equal the integral from 1 to 3 of the magnitude of r prime of t. Some common mistakes are to integrate r prime of t instead of the magnitude of r prime of t. You should end up getting an ordinary Calc 1 integral. You're just integrating a function of t without any vectors at the end. So first let's calculate r prime of t. And to do that, you take the derivative of each component with respect to t. So the derivative of t is 1. The derivative of t squared over 4 is t over 2. And then the derivative of the natural log of t is 1 over t, and then there's a 2 in the bottom, so it's 1 over 2t, like this, and then comma, oops, be careful, the derivative of 6 is 0, right? Now we need to find the magnitude of this. That's the square root of 1 squared plus t over 2 minus 1 over 2t squared plus 0 squared. And that's going to equal I guess we're going to have to distribute. So we're going to get 1 plus, and then t over 2 in parentheses squared is t squared over 4. And then you get minus 2 times t over 2 times 1 over 2t, and then plus 1 over 2t in parentheses squared, that's 1 over 4t squared. And this is going to be the square root of 1 plus t squared over 4. Okay, what are we going to get here? The t's are going to cancel, and then you have a 2's canceling, and so you have minus 1/2. Plus 1 over 4t squared. And we have to integrate this from 1 to 3. And basically the trick is that we're going to rewrite the thing inside the square root as something squared. And then when you take the square root, those will undo each other. So we have to work with the inside. And I see a 1 minus 1/2, so I can rewrite this as 1/2 plus t squared over 4 plus 1 over 4t squared. Now to simplify this, let's write everything in terms of a common denominator. So our common denominator is going to be what? 4t squared, right? So how am I going to work with this 1/2? I have to multiply the top and bottom by 2t squared. So I'm going to get a 2t squared here. For the t squared over 4, what do I need to multiply top and bottom by? T squared. So this will give me t to the 4th. And then I'm going to get a 1. So I'm going to get the square root. Let's rearrange things so that's like this, t to the 4th power plus 2t squared plus 1 over 4t squared. Now this, do you see how you might be able to simplify this part? Let's say that we use the letter u for t squared. Then the numerator is going to be u squared plus 2u plus 1, and that's going to factor as u plus 1 in parentheses squared. So this is like a kind of recognizing the pattern. And u is equal to t squared, and so this is going to be t squared plus 1 in parentheses squared. And then this is going to be over. Now 4t squared, how can I write that as something squared? That's 2t in parentheses squared. Right? Now this is going to be the square root of t squared plus 1 over 2t all squared. So now I have something squared and then the square root, and then when I simplify that, that's going to give me t squared plus 1 over 2t. Now this is only true, by the way, if the inside, the thing that you're squaring and then taking the square root of, is positive or 0. But t is positive, right? T is going from 1 to 3, and so this thing is going to be positive. Okay. So this is my magnitude of r prime of t. And I need to integrate this. So how can I integrate this? I want to split up the fraction, right? I want to split this into t squared over 2t plus 1 over 2t. That's going to be t over 2 plus 1 over 2 times 1 over t. And now I integrate this from 1 to 3. The integral of t over 2 is what? So it's 1/2 t, so I have a t squared, and then divided by 2, so I get t squared over 4, and then plus 1/2 times the natural log of t. Technically it's the absolute value of t, but since t is positive, the absolute value doesn't change anything. So I need to evaluate this from 1 to 3, and I get 3 squared over 4 plus 1/2 times the natural log of 3 minus parentheses 1 squared over 4 plus 1/2 times the natural log of 1. How does this simplify? 3 squared is 9, so I get 9/4, and then I have plus 1/2 times the natural log of 3, and then I get minus 1 squared over 4 is 1/4, and then natural log of 1 is 0, right? That's 0, so 1/2 times 0 is 0. And then this is going to give me (9/4 minus 1/4 is 8/4, that's 2. So get 2 plus 1/2 times the natural log of 3, and that's the answer. The hard part is figuring out how to simplify this absolute value, not the absolute value, the magnitude of r prime of t. And the idea is to get everything in terms of a common denominator, and then recognize that this expression can be factored as as t squared plus 1 in parentheses squared. So basically this problem was set up so that you'd be able to remove this square root, right? That's in the integral. So once you write the magnitude of r prime of t like this, then it's not very difficult to finish the problem, to just do the integral. Okay, thanks.